Hi everyone, welcome to MathWorld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for October-November 2023, and the code is 9709/33. So let's get started. So first question, find the sets of values of x satisfying the inequality modulus of 2 to the power of x plus 1 minus 2 less than 0.5, giving your answer equal to 3 significant figures. So first of all, I will rewrite the question. Now for your information, if let's say modulus x is less than a, that means this x is between minus a and a. Okay, so from here, I will just write 2 to the power of x plus 1 minus 2 is between 0.5 and minus 0.5. Okay, so from here we need to find the x value. That means now I have to eliminate the minus 2 in the middle term. Okay, so that means I have to plus 2 for the whole inequality. So here I plus 2. That means you will be getting 1.5 less than 2 to the power of x plus 1. Then less than 0.5 plus 2, it will be 2.5. Okay, and then we have another formula here. A to the power of m plus n is basically a to the power of m times a to the power of n. Okay, so I need to apply it here. So then I will get the x later on. So this is actually the same as 2 to the power of x times 2 to the power of 1. So then from here, I will divide the whole inequality by 2. Okay, then you will get 1.5 divided by 2 less than 2 power of x less than 2.5 divided by 2. Then I will be getting 0.75, and then here is 1.25. Okay, so to get the x, I will take ln both sides. I will take ln for all the terms here. So it will be ln 0.75 less than ln 2 to the power of x less than ln 1.25. So then, for the middle term, ln a to the power of b, it will be b ln a. So that means this x will be brought down. Okay, then I will be getting ln 0.75 less than x ln 2 less than ln of 1.25. Then from here, ln 2 is basically more than 1. Okay, ln 2 is basically positive. I would say ln 2 is basically positive. So now I need to get the x, means that I have to divide the whole inequality by ln 2. So as long as it's divided by a positive number, then you do not need to change the inequality sign here. Okay, so you just remain these two signs. So what we do here is I just divide the whole inequality by ln 2. Okay, then from here, just calculate the value. So the first one is going to be negative 0.415, and then the next value is going to be 0.322. So that is the solution of this question. Okay, next question number 2. On an Argand diagram, shade the region whose points represent complex numbers z, satisfying the inequalities. There are two modulus here, and one modulus, another one is a number. Okay, so basically for the first one, you need to express in the general form. So the general form is to get the points. So I will always write z minus, then whatever inside the bracket will be the general point. So it will be the fixed point. Okay, so it will be 1 minus 2i. Less equals to z minus 0 plus 0i. So from here, I will get 2 points. So the first point is with coordinates 1 and minus 2, which will be the real and imaginary parts. And then another point will be 0 and 0, which is the origin. Okay, so for the next inequality, this is basically a circle. So I will express in the general form, which is z minus 2 plus 0i, then less equals to 1. So this is a circle equation with center coordinates 2, 0. Because of 2 plus 0i, then the radius, it will be 1 unit. Here is the 1. Okay. So now from here we can start drawing the Argand diagram. So here I will draw two axes. This is the real axis. This is the imaginary axis, and the horizontal will be the real axis. Okay, this is 0. Then here we need to get 1 minus 2. So let's say here is 1. Then here is 2. Because the center of the circle is at 2. Then the radius is 1. So I need to get up to 3 here. So the y value will be minus 1, minus 2. I think that's all. Okay, so now here I will mark the 2 points. So the first point is with coordinates 1, negative 2. So 1, negative 2. Another one is 0, 0. So basically this is perpendicular bisector when it is equal sign. Okay, so it means that now I have to join these 2 points. So we'll draw, please measure the x and y axis, I mean the horizontal and vertical axis. Okay, then make sure you get a perpendicular bisector. So let's say the midpoint is somewhere here. Right? So now you just join. Okay, join the 2 points. So looks like my axis, my scales are not similar, so I'll redraw. So that's why you must measure, okay? So make sure here and these 2 distances are the same. So please measure using ruler. Then now I will get another point, which is 1, negative 2. So here. So the middle value, I need to join these 2 points and get the midpoint. So roughly here, the midpoint. So now when I join, right, so I will get something like this. Okay. So now I have to draw another one, which is a circle with center 2, 0. So this is a 2, 0, and then the radius is 1. So it means that it will be passing through, it will be touching, okay, touching 1 unit above from the center, then to the left side and bottom. So now draw the circle. So draw a smooth circle. Okay, so from here, I will label the circle equation as modulus z minus 2 equals to 1. Then this green color line is basically modulus z minus 1 plus 2i equals to modulus z. Okay, so now I have to decide where is my region. So obviously, when you look at here, less equals to means that it will be all the points inside the circle. Okay, so then for the first inequality, this means the distance from a general point to 1, negative 2 is less equals to the distance from the general points to the origin. So let's say my general point is here, 0. Let's say my point is here. Okay, so from here, when you check, so the distance from the general point Okay, because my points must be inside the circle. So it's just that whether it's upper part or lower part. So if I take this point, so this is a distance, which is the first distance here. And then from here to 1 negative 2, sorry, from 1 negative 2 means that this is the first distance, this is the second distance. So obviously this distance is lower. Okay, the second distance is lower, I mean shorter than the first distance. But then this is our first distance, this is the second distance. So now we need, first distance is smaller than the second distance. So obviously we cannot accept this point. So we have to accept the points below the green line. Okay, so that means now I have to cancel this. So this one will not be my point. So now you can double confirm using another point. Let's say this is my point. Okay, so the distance from this point to here to the first fixed point, which is 1 negative 2, obviously is shorter than the distance from this point to the origin. That means it satisfies this inequality. Okay, therefore I can accept this point, which means all my region, I mean my z value will be below the green color. Okay, the green line. Alright, so that's the working for this question. Okay, so with this we have done this Argand diagram. Okay, now next question number 3. The polynomial this is denoted by px. So now I will write down first px is 2x cubed plus ax squared plus bx plus 6. Now when px is divided by x plus 2, the remainder is minus 8. So x plus 2, you just let it be 0, let the divisor be 0, then your x is minus 2, which means p of minus 2 equals to negative 38. Okay, so from here, I will just direct replace. So I will replace this px by negative 38, and I will replace the x by negative 2. Okay, so I will be getting negative 38 equals to 2 times negative 2 cubed plus a brackets negative 2 squared plus b brackets negative 2 plus 6. Then from here, when you simplify, you get negative 38 equals to minus 16 plus 4a minus 2b plus 6. Therefore, from here, I will get 4a minus 2b. So by moving all the constants from the right side to the left side, okay, then you will be getting negative 28. And now from here, I notice that all of this can be divided by 2. So therefore, 2a minus b equals to minus 14. This is my first equation. Okay, I get this when the px is divided by x plus 2, remainder is minus 38. Now, when the px is divided by 2x minus 1, remainder is 19 over 2. And then you need to find a and b. So, which means now I will let 2x minus 1 be 0. Therefore, my x is going to be half, which means p half equals to 19 over 2. Then from here, I will expect to get another equation. So now again, you substitute back into your px. So I will be getting 19 over 2 is 2 times the x is half. So half cubed plus a times half squared plus b times half, then plus 6. Okay, then from here, when you simplify, 19 over 2, the first one on the right side, it will be 1 over 4. Then plus 1 over 4a plus 1 over 2b plus 6. Okay, and again, when I simplify, I will be getting 1 over 4a plus 1 over 2b equals to 13 over 4. So for all these terms, since it's divided by 2 and divided by 4, I can just times the whole equation by 4. Then I will be getting a plus 2b equals to 13. Okay, now since the first one I have 2a minus b is negative 14, then from here I will be getting A as a subject. So I let my A be 13 minus 2B and let this be the second equation. So now I just need to solve the first and second equation in order to get the A and B. So now substitute second equation into first equation. You will be getting 2 bracket 13 minus 2B, then minus B equals to negative 14. Okay, then you will be getting 26 minus 4B, then minus another B equals to negative 14. Hence, 5B equals to 40. Okay, when I move this B to the left side and the negative 14 to the move the B to the right side and move the negative 14 to the left side. Then from here, I will be getting my B as 8. So once you get the B as 8, then I can just find my A from the second equation. So now my A is going to be 13 minus 2 times 8, which is minus 3. So then I will get A is negative 3 and then B is positive 8. So that's the solution of this question. Okay, question number 4. Solve the quadratic equation. This is a quadratic equation, giving you answers in the form x plus iy, where x and y are real. So now, since you have the w here, alright, w squared and w, and your answer in x plus iy, which means you look at here. Since the coefficient for the w squared is a complex number, that means your w must be a complex number. Okay, so now from here, I will just copy first. Now, basically, the 3 minus I is a constant, okay, because this is without the w. So now your coefficient in terms of x, now your equation in terms of, instead of in terms of x for the quadratic equation, now becomes in terms of w. That means now the coefficient for w squared is 3 plus I. Then the b is the coefficient of the w, which is negative 2. Then the c is the coefficient, is the constant, which is 3 minus I. So now we will compare with the general quadratic equation. Okay, and then now I will solve using quadratic formula. This is the quadratic formula. Alright, so now if your equation in terms of x, then you'll be getting x. But now since our equation in terms of w, that means I will be getting w. So but then use back the same formula. So it will be negative b plus minus square root of b squared minus 4ac over 2a. So this is going to be 2 plus minus square root. Okay, negative 2 squared is 4. Negative 4 bracket. Now, for your information, these two are complex number and conjugate. So if you have a plus bi multiply with a minus bi, it is basically a squared plus b squared. Okay, real squared plus imaginary squared, which means now here I will be getting 3 squared plus 1 squared. Then over 2 times 3 plus I. Then from here, I will be getting 2 plus minus. Okay, so when you check this calculation, this is 10. Okay, 3 squared plus 1 squared is 10. 10 times 4 is negative 40. So 4 minus 40 is basically negative 36. So I will write negative 36, then over 2 bracket 3 plus I. So the square root of minus 1 is I. So now square root of negative 36 is basically square root of negative 1 times square root of 36, which is 6i. Okay, because square root 36 is 6. Therefore, now here I will be getting 2 plus minus 6i over 2 times 3 plus I. So now the 2 can be cancelled off. Okay, so when you cancel off, this is going to be 3. So I will be getting, this is going to be 1 plus minus 3i over 3 plus I. But then when you look at the question here, your answer will be x plus iy, where x and y are real. That means now we need to solve the division of two complex numbers. Okay, so when w is 1 plus 3i over 3 plus I, okay, so to solve this, I have to times the conjugate of the denominator. So the conjugate is 3 minus I, okay? 3 minus I. Then now, for the denominator, it is the same formula here. See here? Or I would say that it is the same result. These two times together, it will be 3 squared plus 1 squared, which is 10. So I will just change the denominator into 10. Then for the numerator, I will just do expansion. So 1 times 3 minus I, and then followed by 3i times 3 minus I. So this is going to be 3 minus I, because 1 times 3 minus I, you get back the original. Then plus 3i times 3 is 9i. Then minus 3i times I, 3i squared. Okay, and again, now if you still remember, this I square is basically minus 1. So I will get positive 3 for the last term. Alright, positive 3 together with the 3 in the first term, it will be 6. Then minus I plus 9i, it will be plus 8i. Then divided by 10. Now I will split it into two terms. Then it will be 6 over 10 plus 8 over 10i. Then when you simplify, it will be 3 over 5 plus 4 over 5i. So I get the first w value, okay, the first complex number. Now, don't forget to consider the negative. So when w is 1 minus 3i over 3 plus I. So then use the same method to simplify. Then you will be getting 1 minus 3i over 3 plus I times by 3 minus I over 3 minus I, the conjugate of the denominator. Again, the denominator will be the same, which is 10. Now, for numerator, same method as just now, just do expansion. So 1 times 3 minus I, you will get back the same complex number. So minus 3i times 3, it will be minus 9i. So minus 3i times minus I, it will be plus 3i squared. Then from here, this I square is minus 1. Okay, so I will get 3 minus 3 for the real part. Then you will be getting 0. Then for the imaginary part, it will be negative 10i. Then over 10. Okay, imaginary parts will be negative 10. So from here, when you simplify, at last you are getting minus I, which means our final answer, it will be 3 over 5 plus 4 over 5i. Another one is negative I. Okay, so that's the solution of this question. Okay, next question number 5. Find the exact coordinates of the stationary points of the curve. So whenever you see stationary points, means that dy over dx equals to 0. And then it's mentioned points here, means that you will be getting more than one point. So now the y is e 3x squared minus 1 over 1 minus x squared. So obviously this is the quotient rule. Okay, this question must be solved using quotient rule because it's a division. So our quotient rule is d over dx u over v, which is over v squared. Then numerator you rewrite the denominator, then u prime minus uv prime. So now I will write down the u first. My u is e 3x squared minus 1. So now my u prime, now to differentiate exponential function. So differentiate exponential function, it is just to rewrite the whole exponential function, and now you differentiate fx to get the f prime x. Okay, which means you rewrite the whole e, Then you differentiate the power of the e. So when you differentiate 3x squared minus 1, it will be 6x. So when I rewrite, I will get 6x e 3x squared minus 1. Then my v is 1 minus x squared. So v prime, it will be negative 2x. Right, so now my dy over dx, according to this quotient rule, it will be over square the denominator. Now v u prime, so v is a quadratic, u prime is 6x exponential 3x squared minus 1, then minus, keep the exponential, and v prime, so v prime is negative 2x. Okay, then now I need to simplify. So from here, I notice that the common term is the exponential. So I will factorize the exponential function. Then for the first term, you still have 6x times into the bracket. So here I will be getting 6x times 1 is 6x, then minus 6x times x squared, so 6x cubed. Okay, and for the next one, you see here is minus, here is minus 2x. Therefore, it will be positive 2x. Right, then I will be getting plus 2x. And then over the square. This is our dy over dx. But then stationary points means dy dx equals to 0. So you let it be 0. When you let it be 0 means that the numerator equals to 0. So I know that e 3x squared minus 1 multiplied with this is going to be e 3x squared minus 1. I can simplify the first and third term. Therefore you are getting 8x minus 6x cubed. So it means that the numerator will be 0 when the dy dx goes to 0. But then we know that exponential is always positive. Okay, the exponential function cannot be 0. Hence, 8x minus 6x cubed equals to 0. So to solve this, I can factorize 2x, which is a common term. Then you'll be getting 4 minus 3x squared. So multiplication of these two terms equals to 0 means that either 2x equals to 0 or 4 minus 3x squared equals to 0. So for the first one, when 2x equals to 0 means x equals to 0, then the other one, 4 minus 3x squared equals to 0 means that 3x squared equals to 4. Therefore, your x squared equals to 4 over 3. Then I will get my x as plus minus square root. Okay, plus minus square root, or I would say 2 over square root 3. So you can leave your answer in this form, or if you do not prefer square root in the denominator, just times square root 3, then over square root 3. Then you will be getting plus minus 2 square root 3 over 3. So these are the x values. But then when you look at the question, it's mentioned exact coordinates of the stationary points. Means now we need to find the y. So you have to substitute the x values that you have found into the curve equation, which is this y. Okay, so now when x equals to, or I will write y equals to e 3x squared minus 1 over 1 minus x squared. So when x equals to 0, my y is going to be e0 minus 1 over 1 minus 0. That means e0, okay, wait, this minus 1 is the numerator, is the power. So I will get e negative 1. Okay, e negative 1 is basically 1 over e. Then now when x equals to 2 square root 3 over 3, which is this value, then my y is going to be exponential 3 2 square root 3 over 3 squared it minus 1, then divided by 1 minus 2 square root 3 over 3 squared. Okay, so this one probably I rewrite that. Then here you will be getting negative 3e, or probably I will just rewrite first. This is going to be e cubed over negative 1 over 3. Then I will be getting negative 3e cubed. Okay, so now where x equals to negative 2 square root 3 over 3, the y is exponential 3 bracket negative 2 square root 3 over 3 squared minus 1, then over 1 minus negative 2 square root 3 over 3 squared. Then again, this will be same as previous calculation, which is negative 3e cubed. Then now we have solved the 3 stationary points. It will be 0, 1 over e, and then 2 square root 3 over 3, and then negative 3e cubed. Another one is a negative x. So these are the 3 stationary points. So hang on please. Okay, so done for this question. Now for question number 6a, show that the equation can be written in this form. So in terms of sine theta. So now cot squared theta plus 2 cos 2 theta equals to 4. So the cot squared is basically cos squared theta over sine squared theta. Then for the cos 2 theta, okay, since we need to get the answer in terms of sine, so I will write 1 minus 2 sine squared theta. Okay, because we have a formula here. Cos 2a equals to 1 minus 2 sine squared a. Right. So now from here, that equals to 4. So from here, I will times the whole equation by sine squared theta because I need to eliminate the denominator. Then I will be getting cos squared theta plus 2 sine squared theta multiply with 1 minus 2 sine squared theta. For the right hand side, just times by sine squared. So 4 sine squared theta. Okay, then from here, I will do expansion. At the same time, the term on the left hand side, I will move it to the term on the right hand side will be moved to the left hand side. Then from here, I will be getting cos squared theta. Then the first term is going to be 2 sine squared theta. Then 2 and minus 2 will be minus 4 sine degree 4 theta. This 4 sine squared theta will be moved to left side because negative 4 sine squared theta. Okay, then from here, I will be getting negative 4 sine squared theta. Sorry, sine degree 4 theta. Okay, now you see the first one, the cos squared, right? I need to get sine squared. So it means that I need to change cos squared theta plus sine squared theta is 1. So therefore, cos squared theta equals to 1 minus sine squared theta. So which means this I will change to 1 minus sine squared theta because we don't need cos. Right. Then from here, the term after this, it will be sine squared. So here, negative sine squared plus 2 sine squared and minus 4 sine squared. That means it will be minus 3 sine squared theta. Then left the plus 1. Now we want to show this. Therefore, all the terms multiplied by negative. Okay, times by negative 1. Then I will get 4 sine degree 4 theta plus 3 sine squared theta minus 1 equals to 0. So with this, we have shown the given form. Okay, so next part, B, hence. Hence, solve the equation. So it is the same equation as just now. Therefore, I will just write this cos squared theta plus 2 cos 2 theta equals to 4. It is same as the previous equation, which is this. So 4 sine degree 4 theta plus 3 sine squared theta minus 1 equals to 0. So I will write 4 sine degree 4 theta plus 3 sine squared theta minus 1 equals to 0. Then here, since this is in terms of sine squared theta, I will factorize it into sine squared theta. Okay, so this can be factorized into 2 factors. So you will get 4 sine squared theta minus 1, and then sine squared theta plus 1 equals to 0. And now, either the first bracket equals to 0 or the second bracket equals to 0. So when the first bracket equals to 0 means that sine squared theta equals to 1 over 4. Okay, then your sine theta will be plus minus half because you take the square root. But then for the second term, sine squared theta equals to minus 1. We know that whatever value after you square, it will not be negative unless it is complex number. So obviously your theta is not complex number, therefore there's no solution. Okay, so it means that now we just need to solve sine theta equals to plus minus half for this interval. Which means now I have to consider all 4 quadrants. So the basic angle here is inverse sine half. So inverse sine half is going to be 30 degrees. Okay, but then our angles will be, first is 30 degrees, the second is this major angle, then this is the third and the fourth. Okay, so now I will be getting theta equals to 30 degrees, which is our angle in the first quadrant. Then the second quadrant is 180 minus 30 degrees. And then the third quadrant is 180 plus 30 degrees. And then the last quadrant is 360 degrees minus 30 degrees. So at last, you will be getting 30 degrees, 150 degrees, 210, and 330. So these are the angles that satisfied by the equation. Okay, so done for this question. Next question, number 7. The equation of a curve is this, right? Show dy dx. So now this is implicit equation. So when I differentiate x cubed with respect to x, it will be 3x squared. So when you differentiate y squared with respect to x, so we need to apply this implicit differentiation. Alright, so differentiate fy with respect to x. Since these two are different variables, I need to differentiate the fy with respect to its variable first, which means it is a the y. So it means I have to find d over dy fy. But then when you compare here, the dy is extra, I need dx. That means it's like you are multiplying dy then over dx. So it looks like we are cancelling the dy. Then you will be getting the left hand side. Okay, so that is the way we differentiate the implicit function. Okay, so now first of all, when I differentiate y squared with respect to y, it will be 2y, then always times by dy dx. So the third term is when you differentiate 3x squared, it will be 6x. Then the 3y becomes 3 dy over dx. Okay, then equals to 4. The 4, because there's no x, is a constant, then you get 0. Then from here, I will group the terms with the dy dx, which means 2y dy over dx plus 3 dy over dx. So then the 3x squared and this 6x will be moved to the other side because I want to get this. Okay, so you see there's a negative here. So now I will get equals to negative 3x squared negative 6x. Alright, then from here I will factorize the dy dx, then 2y plus 3 times dy dx. Then for the right side I will factorize a negative. Then you will get 3x squared plus 6x. Then we will be getting the answer now. So now dy over dx, just move down this bracket. So it will be negative 3x squared plus 6x divided by 2y plus 3. So this is the given form. So we have proven, or we have shown the dy dx. So done for question 7, 8. Now for question B, hence means use a previous answer. Find the coordinates of the points on the curve at which a tangent is parallel to the x-axis. So when tangent is parallel to the x-axis, that means dy dx goes to 0. Okay, so now I will rewrite my dy dx. This is my dy dx. So now my dy dx equals to negative of 3x squared plus 6x over 2y plus 3. When dy dx equals to 0, that means the numerator is 0. So 3x squared plus 6x equals to 0. Then from here, to find the coordinates of the points, you see, points means that more than one point. Therefore, here I should get more than one x. So I will factorize the 3x. Then you will get x plus 2. Then here, I will either get 3x equals to 0 or x plus 2 equals to 0. Then my x equals to 0 or x equals to negative 2. So with the 2x, I can get the points, right? More than one point. So now for the y coordinate, I have to substitute into this equation. So here I will rewrite the whole curve equation in order to get a y coordinate. So which means I will get from the curve equation, so when x equals to 0, so I will get y squared plus 3y equals to 4. Then now y squared plus 3y minus 4 equals to 0. And then here I will factorize this quadratic equation. So that will be y minus 1 times y plus 4 equals to 0. Which means now y minus 1 equals to 0 or y plus 4 equals to 0. Then I will get two y values. Okay, now when my x is 2, is negative 2, sorry, x is negative 2, then I will get substitute all this. No, negative 2 cubed plus y squared plus 3 times negative 2 squared plus 3y equals to 4. So from here I will get minus 8 plus y squared plus 12 plus 3y equals to 4. Therefore, y squared plus 3y equals to 0. Okay, so then the y is in common. Take out the y or factorize the y. Then now either y equals to 0 or y plus 3 equals to 0, which means y equals to minus 3. So remember, I get all this when the x is 0, I get 2y. Okay, and when my x is minus 2, I also get 2y. Therefore, all these will be my stationary points. So it will be 0, 1, 0, 4. Sorry, 0 minus 4 because the y is negative 4. And then x is negative 2, y is 0. X is negative 2, y is negative 3. So these are the 4 stationary points when the tangent is parallel to the x-axis. Okay, next question, number 8. The variables x and y satisfy the differential equation given y equals to 0 when x equals to 2. Find the expression for y in terms of x. So now, e for x dy over dx is cos square 3y. Now, since your dy is the numerator, that means the y should be in the should be on the left hand side. Okay. So therefore, I need to move the cos square 3y to the left side. So I will get 1 over. Because it's like this multiply with 1. So that's why when I move, I will have to divide. Then here is dy. Then my e 4x will be moved down or moved to the other side. So it becomes 1 over e 4x. Then the dx move up. So once you have split the variables, integrate both sides. Now, when you integrate this, before I integrate, I have to simplify first. 1 over cos square 3y is basically secant square 3y. Then 1 over e 4x, I have to move up the e. So it becomes negative 4x. Alright, so then you have to integrate term by term now. So when we integrate tangent, when we differentiate tangent x, you will be getting secant square x. That means if I integrate secant square x dx, I will be getting tangent x plus c. So that means now for the secant square 3y, I will be getting tangent 3y. But then since this is 3y there, so I have to divide by differentiation of 3y, which is 3. So even though both sides without limits, I will not plus the arbitrary constants both sides, but I will just plus it at, on the right side. So then integrate exponential ax plus b dx, you have to rewrite the whole exponential function and then divide by the differentiation of the power of the e. So when differentiate ax plus b, it will be a followed by plus c. Okay, which means in this case it will be e negative 4x over negative 4 then plus c. So now to find the c, to get the c, replace the x and y values. So x by 2, y by 0. So x equals to 2, y equals to 0. So the left hand side tangent 0 over 3. Right hand side is e negative 4 times 2. So I get 8 over minus 4 plus c. So for your information, tangent 0 is 0. So it means that this exponential term just moved to the other side. That will be your c value. Then I will be getting c equals to e negative 8 over 4. So once you have found this c, substitute this c into the solution. That means now I will be getting tangent 3y over 3 equals to e negative 4x over negative 4 plus e negative 8 over 4. Okay, so now before we proceed, refer back to the question. You need to leave your answer for y in terms of x. Okay, so it means that now I need to times the whole equation by 3 because I need the y as a subject. So now I times 3, tangent 3y equals to, okay, now if you notice that for the right side, over both terms also over 4 means that I can factorize the over 4. So then the over 4 together with the times 3, it will be 3 over 4. So I will write 3 over 4, then negative e negative 4 plus e negative 8. Okay, negative 4x, sorry, negative 4x. Then I need to get the y, so the tangent will be moved to the other side, becomes inverse tangent. So then I will write 3y is inverse tangent of the right side. Okay, if you don't prefer the negative as the first term, I will just switch with the second term. Okay, so at last you will be getting the y, which is 1 over 3 of the inverse tangent. So this is the solution of this question. Alright, so let's move on to next question. Question number 9. Let fx be the rational function. Express fx in partial fractions. So first of all, I will rewrite the function. So before you proceed, right, let's check. The highest degree for x in the numerator is 2, but when you do expansion in the denominator it becomes 3. That means this is the proper rational function. Hence the polynomial division is not needed. Okay, then we can just direct find the partial fractions. Now for partial fractions, look at the first term. This is a quadratic that cannot be factorized. Then we have to rewrite. And then the numerator is a linear function, so ax plus b. Now, the next one is 2 minus x. This is a linear factor, therefore, numerator is a constant c. Now, to find all the unknowns a, b, c, we need to always compare with the left side in order to get the same denominators, which means now I will rewrite my left-hand side. Then here, just rewrite the first term. Now, when you compare with the left-hand side, I have the quadratic factor, which means now I need to times with 2 minus x for the numerator and denominator. Then plus c over 2 minus x times with, okay, now you are given 2 minus x. That means you need to times with the quadratic. So this is going to be 2 plus 3x squared over 2 plus 3x squared. Alright, so now when we get the same denominator, so basically we can just ignore all the denominators. Then now I will be getting my numerators. Okay, now to get the unknowns, I will let the factor be 0. So now, firstly, I will let 2 minus x be 0. That means the x is going to be 2. So now substitute 2 into the whole equation. So I will get 17 times 2 squared minus 7 times 2 plus 16. But then now, when you look at the question here, since I let this be 0, that means the whole bracket, the whole term on the right side, okay, the first term on the right side will be 0. Then I can find the C directly. So which means here I will get C bracket 2 plus 3 times 2 squared. Okay, so for the left hand side, it will be 70. Right hand side, it will be 14, C. So then your C is 70 over 14, which is 5. Now, supposedly we need to let this another one be 0. Okay, we need to let this be 0. But then we know that quadratic cannot be 0. Right? 2 plus 3x squared cannot be 0. So it will be always at least 2. Therefore, I will let x be any other numbers. So the easiest way is just let x be 0. Right. So for the left hand side, first term 0, second term 0, third term is 16. Then a times 0, no more, then plus b. So b bracket 2 minus 0, I'll get 2 here. Plus c bracket 2 plus 3 times 0, so it's just 2. We refer to this equation. Just now we have found the c, just replace the c. 16 is 2b plus 2 times 5. So that means here 2b, okay, 2b equals to 16 minus 10, which is 6. Hence my b is 3. Alright, so found the c and b. To find the a, you just let x be any other numbers. I will let x be a smaller number, let's say 1. So my left hand side will be 17, 1 squared minus 7 times 1 plus 16. So now you have to replace all the x by 1. All this x by 1. Then I will get a. A times 1 is a. So a plus b. The b is 3. Then 2 minus 1 is 1. Plus the c. C is 5. Then 2 plus 3 times 1 squared is 5. Okay, so the left hand side you will be getting 26. Then this is going to be a plus 3 plus 25. Therefore, your a is going to be 26 minus 28, which is negative 2. So once you have found all the 3 unknowns, okay, these are the 3 unknowns. Then I will just substitute back into my general form of the partial fractions. Okay, so you can just write 17x squared minus 7x plus 16 over 2 plus 3x squared bracket 2 minus x. It will be a is minus 2, so minus 2 over 2 plus 3x squared. Then now you check here. It will be ax plus b. So it means that minus 2x, the b is 3. So plus 3. Alright, so the minus is just for the 2. After that, plus c over the other factor. So the c is 5. So I'll write 5 over 2 minus x. So this will be the partial fractions. Plus b. Hence, obtain the expansion of fx in ascending powers of x up to and including the term in x cubed. So now to do the expansion, I need to use back these two terms. Okay, so I will have to write fx equals to negative 2x plus 3 over 2 plus 3x squared. Then plus 5 over 2 minus x. So from here, I will write this is basically negative 2x plus 3. Move up the denominator, it will be 2 plus 3x squared degree negative 1. Then plus 5 times 2 minus x to the power of negative 1. Okay, so since both terms with power of negative 1, that means I have to use this binomial expansion. 1 plus x to the power of n, it will be 1 plus nx plus n minus 1 over 2 factorial x squared plus, because it's up to x cubed, so it will be n minus 1 n minus 2 over 3 factorial x cubed. Okay, there are two conditions for you to use this binomial expansion formula. The first one is it must be positive 1. Okay, and then the second is plus x. The operation is plus. So from here, I need to change to this general form first. So I notice that the first term here is 2. So to make it to 1, I have to factorize 2. Therefore, you will be getting this. Okay, here is already plus, so no problem. Then now, plus 5. Here is 2. I have to factorize a 2. Then it becomes 1 minus x over 2 to the power of negative 1. Okay, and again now the minus cannot be accepted. What to do is we change it to plus and minus. So which means this will be, okay, I rewrite. This is going to be plus, after that minus. Okay, so now I will rewrite minus 2x plus 3. For your information, right now, this degree minus 1 you have to bring into both of this. Right, that means I will get 2 to the power of negative 1. Then 1 plus 3 over 2x squared to the power of negative 1. Same goes to the next one. So the next one, this minus 1, you have to bring it into to these two terms. Alright, so I will be getting plus 5, 2 power negative 1, then 1 plus negative x over 2 to the power of negative 1. Okay, so now we already found this form. We already expressed in this general form, I would say. That means you can just apply the formula. So I will get, now this 2 power negative 1 is half, so I will bring it to the front. So it will be half of negative 2x plus 3. Then for this power of negative 1, this term, I will apply this formula. Okay, so now your n is minus 1, and then this x becomes 3 over 2x squared. Therefore, I will be getting 1 plus, the n is minus 1, then x, so 3 over 2x squared is my new x, then plus n is minus 1, then n minus 1 becomes minus 1 minus 1, so minus 2 over 2 factorial. After that, 3 over 2x squared, you squared it. Okay, that is my new x squared. And then plus n minus 1, n minus 2, sorry, n minus 1 is, so minus 1 becomes minus 2, then minus 1 minus 2 becomes minus 3 over 3 factorial, then the new x cubed. Because as requested in the question, you have to expand until x cubed. Okay, so we will stop here for the expansion. Or actually, we don't need this term because when you look at the question here, this is already x degree 4. Okay, so basically I don't need this term, so I overlook it. So I can stop in the previous expansion. Right? And now, for the next one, you have to solve this. Okay, so 5 times 2 power negative 1. The 2 power negative 1 is actually half. So I will write plus all this plus with 5 times half. Then for the other expansion, okay, so here for this expansion, use the binomial expansion formula. So this is going to be 1 plus the n is minus 1. Now your x is negative x over 2. Then plus n is minus 1. Then minus 1 becomes minus 2 over 2 factorial. Then the new x, you squared it. So here we still need to continue for next term because you are just getting x squared. It's not enough. We need to get up to x cubed. Then here minus x. Okay, I have not enough space, so I will just consider next line. I will just continue next line. Okay, so now simplify all these terms. So, okay, I bring in this half, then I will get negative x plus 3 over 2. Okay, so this is negative x plus 3 over 2. Then the whole square bracket I will simplify. You will be getting 1 minus 3 over 2 x squared. Now basically, this term no need to simplify because this is already x degree 4. We just need up to x squared. Alright, so it means that now I will just ignore the expansion and then I simplify the next expansion. So this is going to be 5 over 2. So this is plus 5 over 2. So then the bracket, it will be 1 plus x over 2. Okay, simplify all these terms. Then you will be getting 2 more terms. So the next term is plus 1 over 4 x squared, followed by plus 1 over 8 x cubed. Okay, then from here, again, the minus x multiply with the whole bracket, followed by 3 over 2 multiplied by the whole bracket. So I will be getting negative x plus, okay, negative x times this, so it will be plus 3 over 2 x degree 4, x degree 3. Then the 3 over 2 times 1 is 3 over 2. 3 over 2 times minus 3 over 2 x squared, it will be minus 9 over 4 x squared. And then next is to times 5 over 2 inside into the square bracket. Then I will be getting plus 5 over 2 plus 5 over 4x plus 5 over 8 x squared, and then plus 5 over 16 x cubed. Okay, then now lastly simplify. So then from here, for the constant, I will have 2 constants here, 3 over 2 plus 5 over 2. So we get 8 over 2, which is 4. So that is 4. Okay, then followed by minus x, then plus 5 over 4x. Okay, so you will get plus 1 over 4x. Then for the x squared, so the summation of these two terms, you will be getting negative 13 over 8 x squared. Lastly, for the x cubed, you will be getting 29 over 16 x cubed. So this will be the expansion up to x cubed. Okay, C, state the set of x values for which the expansion in B is valid. Give your answer in exact form. Okay, so for the expansion to be valid, let's go back to the original form. So this form is valid, this expansion is valid when the modulus of the x is less than 1. Okay, so that means we have to refer to the general form, which means here I need to let the modulus of this and this less than 1. Okay, these two. So I will write modulus 3 over 2 x squared less than 1. Another one is modulus of negative x over 2, okay, which is here. So I need to find the common x that's satisfied by both inequalities, which means now when I bring out the constants, or I take out the constants, I will get modulus x squared less than, this is going to be 3 over 2, less than 1. Then modulus x squared is less than 2 over 3. Okay, then the modulus x will be less than square root of 2 over 3. Alright, and then for the next one, it will be modulus of, okay, this is same as positive, modulus of positive. Then the over 2, you can write modulus x times half. Okay, or I would say half modulus x less than 1, hence modulus x less than half. Okay, so from here, oh sorry, this is half, so the half you move to the other side is 2. Okay, mistake here, this is 2. Now we know that 2 is basically square root 4. So then this is only square root 2 over 3, which means we will take the smaller number. It's like here. Okay, it's like this. This less than 2 is basically between minus 2 and 2. Okay, this is between modulus, negative square root. So this will be the explanation. So for the first inequality, it will be from minus 2 to 2. And then for the second inequality, it will be between the negative square root and the positive square root. Okay, so now this is the common region that's satisfied by both inequalities. Therefore, we always take the smallest range. Okay, so this is the set for which the expansion is valid. So next question, number 10. The diagram shows a curve whereby the x is at least 0. Find the equation of the tangent to the curve at the points where x goes to pi over 2. So now, when equation of tangent means that you need the gradient of tangent. So gradient of tangent is the dy dx. So then to get the dy dx, I need to use product rule because this is multiplication of two terms. So now my product rule is d over dx uv equals to uv prime plus vu prime. Okay, therefore my u is x, my v is cos 2x, then my u prime is 1, my v prime, to differentiate cos, it will be negative sign. Copy the 2x, differentiate 2x is 2. Okay, and now use this formula, it will be x times negative 2 sine 2x plus vu prime. So vu prime means cos 2x times 1. Then from here, I will rewrite negative 2x sine 2x plus cos 2x. That is my dy dx. But then it's given that it is at x equals to half pi. So now when x equals to half pi, my dy dx will be negative 2 times half pi sine 2 times half pi. Then plus cos 2 times half pi. So then from here, the negative 2 and half can be cancelled off. Okay, the 2 and half can be cancelled off. Then I will get negative pi. Now this 2 and half again cancel off. You are getting psi pi. Okay, psi pi is 0. So here probably I show step by step working. So it will be psi pi then plus cos pi. So sin pi is 0. Therefore, I will get just cos pi. Cos pi is minus 1. Okay, because this is minus 1. So I found the gradients of tangent. Then now again, when you need to find the equation of tangents, we need a point. So now the x is given, we need to count what is the y. So when x goes to half pi, the y is x cos 2x. That means this is half pi. Now remember here, cos 2x is this value is cos half pi, which is minus 1. So I will just write here cos pi. Okay, not cos half pi, it's cos pi, sorry. Then here is going to be negative pi over 2. Therefore, my point is with coordinates pi over 2 and negative pi over 2. So now my equation of tangent at pi over 2 and negative pi over 2, use a formula y minus y1 equals to m bracket x minus x1. So this is going to be y minus negative half pi. The m is minus 1. Okay, because we already found the dy dx here, then x minus half pi. Then now I will get y plus half pi equals to minus x plus half pi. So since you get both half pi, that means the half pi will be cancelled off. So at last your y is minus x. So this is the equation of the tangent. Okay, now B, find the exact area of the shaded region shown in the diagram bounded by the curve and the x-axis. Okay, so let's look at the graph first. Now I need to find what is this point. Okay, this point happens when y equals to 0. So now I will write y equals to x cos 2x. So when y equals to 0, that means 0 is x cos 2x, which means either x equals to 0 or cos 2x equals to 0. So when cos 2x equals to 0, right, now let's look at the cos graph. This is 2 pi. Here is 3 pi over 2. Then this is half pi, this is pi, and here is half pi. Okay, which means the cos graph will be 0 at pi over 2 and 3 pi over 2. Okay, so here I will write 2x is between pi over 2 and 3 pi over 2. Then your x will be your 2x equals to half pi and 3 pi over 2. So that means your x will be pi over 4 and also 3 pi over 4. Okay, so now by looking at the graph, since your x is greater or equals to 0 and this point is close to 0, so now we have found 3 solutions, either 0, 1 over 4 pi or 3 over 4 pi, which means now we have to choose 3 over 4 pi, okay, according to the graph. Right, so I have to choose 3 over 4 pi. This is 3 over 4 pi. This is pi over 4. Okay, because it's closer to 0. So now I have to integrate from 0 to 1 over 4 pi for this graph. And the region is above the x-axis, you can just direct integrate. So now I will write my area. Okay, I better to write this. It will be integrate from 0 to 1 over 4 pi the graph. So x cos 2x dx. So to solve this integration, we need to use by parts, integration by parts. Right, integration by parts says u dv over dx equals to uv minus integrate v du over dx. So your u is the x, and this dv dx is the cos 2x. Right, so your u is x. dv dx is cos 2x. So your du dx will be 1. Then the v, when you integrate cos 2x, integrate cos, it will be sine. Then rewrite the 2x, differentiate 2x, it will be over 2. So now substitute into this formula. Now for your information, if the integration with limits, because here we have 0 and pi over 4, so with limits ab, we have to consider limits as well. Alright, so this will be the definite integral for integration by parts. Then I will substitute into the formula. This is going to be uv, so x sine 2x over 2 with limits, then minus integrate v du dx, so it will be sine 2x over 2 dx, then with limits as well. Okay, so now firstly you replace the x by pi over 4, so I will get this x is pi over 4, so pi over 4 I will take out the half, then I'll write pi over 4 sine 2 times pi over 4, it will be pi over 2. Then replace the x by 0, so minus 0. Now the over 2 here, this over 2 will be taken out. So I will take out the negative half. Integrate sine, it will be negative cos. Then rewrite the 2x. Differentiate 2x is over 2. Again, limits. Okay, so now for your information, sine half pi is 1. That means first term will be pi over 8. Okay, now this negative and negative is a plus. This over 2 combined with the half becomes 1 over 4. So I will just write plus 1 over 4. Then cos 2x, so it will be 2 pi over 4. 2 pi over 4 is basically pi over 2. So I will just write pi over 2. Then minus, when the x is 0, I will get cos 0. Okay, now for your info, cos 0 is 1. Cos pi over 2 is 0. Okay, then from here, I will be getting pi over 8. 1 over 4 times minus 1, it will be minus 1 over 4. So that is the area. Okay, next question, question 11. The line L has this equation. The points A and B have position vectors minus 2i plus 2j minus k. That means OA is negative 2, 2 minus 1. And then the OB is 3, negative 1, 1. Okay, 3i minus j plus k. So find a unit vector in the direction of L. So this is the L. Right. So now I will write from RL. Okay, the direction vector B is negative 1, 1, 2. We get it from here. So now since it's mentioned units vector means that we have to divide by its magnitude. So the magnitude for the B is square root of negative 1 squared plus 1 squared plus 2 squared. That means you are getting square root of square root 6. Okay, square root of 6. Then now units vector in the direction of L is basically B hat. This is 1 over B modulus times, I would say, B divided by its magnitude. then this is going to be 1 over, no, I will write in this form. 1 over square root 6 times the vector b, minus 1, 1, 2. Then you can just times in the square root 6, 1 over square root 6, then you will get negative 1 over square root 6, 1 over square root 6, and 2 over square root 6. So this is your unit vector. Okay, so done for this part. Now, the line M passes through points A and B. Find the vector equation of M. So now I have to find the vector AB. So the vector AB is actually vector OB minus vector OB minus vector OA. So vector OB I have stated on the previous part, which is 3 minus 1, 1. Minus the OA is negative 2, 2 minus 1. Then you will be getting 3 minus minus 2 is 5. Minus 1 minus 2 is minus 3. 1 minus minus 1 is 2. So the vector equation of M, it will be Rm. I can use any points. It will be OA plus, just now we have lambda. So here I use T. So you can either use the OA or OB, up to you. Okay, because it can be any points on the line. So OA will be negative 2, 2, negative 1, plus T, 5, negative 3, 2. So this is the vector equation of the line M. Okay, now, next part, determine whether lines L and M are parallel, intersect, or are skew. So now, I have to write down RL. It will be 1i minus 2j minus 3k. So 1, negative 2, negative 3. Plus lambda minus 1, 1, and 2. Okay, minus I plus j plus 2k. So minus 1, 1, 2. So here is going to be minus 1, 1, 2. Then my Rm, we have just solved it in the parts B. Negative 2, 2 minus 1. Negative 2, 2 minus 1 plus T of 5 minus 3, 2. So 5 minus 3, 2. So from here, I will get my B1 or BL. Okay, I will write BL is negative 1, 1, 2. Then my BM, it will be 5, negative 3, 2. So since the BL is not multiple of BM, okay, so I will write it's not S of BM. Therefore, L and N are not parallel. Okay, so now from here I need to check whether they are intersecting or not. So I will let RL equals to RM. So when RL equals to RM, I need to find the two unknowns, which means now I will ignore the brackets. So RL, I will write 1 minus lambda, okay, times in. So then minus 2 plus lambda, then after that minus 3 plus 2 lambda. Then equals to, the RM will be minus 2 plus 5t, 2 minus 3t, then minus 1 plus 2t. So I let this be 3 equations. Now to solve the t and lambda, I just need to use 2 equations. means that I will be using 1 and 2 because from the first two equations I have negative lambda and positive 1 lambda. So I will eliminate the lambda by adding these two equations. So first plus second equation. Then left hand side 1 plus minus 2, it will be minus 1. Then the lambda will be cancelled off. Minus 2 plus 2 will be 0. Then 5t plus minus 3t will be 2t. Then my t is negative half. Okay, found the t from these two equations. Now to find the lambda, just use first or second equation. We cannot use a third. So now I will use the first. From first equation, okay, I will get minus 2 plus lambda equals to 2. Sorry, I'm using the first equation. So it will be 1 minus lambda equals to negative 2 plus 5t. The t is negative half. Then you will get 1 minus lambda equals to negative 9 over 2. Therefore, your lambda is 1 plus 9 over 2, which is 11 over 2. Okay, so once we have found the t and lambda here, this t and lambda, I have to substitute this into the third equation to check the left and right side separately. So from third equation, my left hand side is going to be negative 3 plus 2 lambda. So this is going to be 8. Then for the right hand side, it's going to be negative 1 plus 2t. Then you will be getting negative 2. So from here, obviously left hand side is different from right hand side. So when difference means that the t and lambda do not satisfy the third equation. So in other words, they are not intersecting. Okay, therefore, both lines are not intersecting. Both lines do not intersect. Now, if both lines do not intersect and also they are not parallel to each other, okay, that means it's definitely they are skew lines. Alright, so just right here, since L and M do not intersect and do not parallel, and are not parallel, then therefore they are skew. Okay, so that's the conclusion of these two lines. Alright, so we have come to the end of the video. Thanks for watching. Please like the video and subscribe to the channel if you enjoy watching my video, and also stay tuned for more upcoming videos. Thank you. Bye.